Hi, my name is Mina Holloway and I'm participating in Challenge 2014. What we're going to be doing today is working through problem number 7 from the exam problems of Math 1000. Number 7 says h of u is equal to tangent cubed of the square root of u squared minus 1. So and they want us to find the derivative of h. The first and most important thing of solving a derivative or finding a derivative is you have to remember chain rule. Chain rule is very, very important. So with that said, we're going to rewrite this a little bit. That way it's easier to solve. So h of u is equal to tangent of the square root of u squared minus 1 and all that cubed. That's this is the same exact thing as what's written up here. It just makes it easier to see and carry out chain rule. So the first step of chain rule is we're going to take this exponent out here and multiply it out front. So h prime of u is equal to 3, and then tangent, and then the square root of u squared minus 1. And then when you solve for the derivative of an exponent, you have to remember that the exponent that's left up here is n minus 1. This is the n and then minus 1. So 3 minus 1 is equal to 2. Moving on, because we're still not done, we're going to take the derivative of tangent. The derivative of tangent is secant squared. So 3 secant squared times the square root of u squared minus 1 squared. That's the first part. We're still not done because chain rule dictates that we have to find the derivative of the inside as well. So 3 secant squared square root u squared minus 1 squared. Alright, all that times the derivative of the inside. The square root of u squared minus 1, basically the square root is equal to a 1/2 power. So anything to the 1/2 power is the square root of that something. So like we did up here with the outside, hold on, I'm going to rewrite this. Basically this translates into u squared minus 1 and all that raised to the 1/2 power. So like we did up there up here when we pulled the exponent out front and then did n minus 1, we're going to do the same exact thing here and find this derivative. So pulling that to the front, we're going to have 1/2 u squared minus 1, and then the n minus 1, the 1/2 minus 1 is going to give us negative 1/2. And that's the second part of the derivative. So right now we have h prime of u equaling 3 times secant squared of the square root of u squared minus 1 squared times 1/2 times u squared minus 1 raised to the negative 1/2 power. We are still not done. There's still a variable with an exponent that we have not derived yet. And so what we're going to do is basically do the power rule, which is one of the easiest derivatizing rules. And we're going to multiply the exponent out front, or out that's beside the variable, out in front of it. So we're going to have 2u, and like we said before with the n minus 1, 2 minus 1 is 1, so we don't really need to put that up there because it's just an identity exponent. We don't have to do anything with the negative 1 because the negative 1 has a derivative. It basically what this is saying is negative 1 times the derivative, the variable u, but because we don't see the u there, the u is to the 0 power, which we all know as 1, that equals 1, so negative 1 times 1 is negative 1. So basically if we were to do this and take the derivative, it'd be negative 1 u to the 0 power. Well, doing this, we'd have 0 out in front, and that's 0, and you just have a ton of zeros, so it's really just 0. So there's no point in writing it. So your full answer to the problem, hold on. h prime of u, the derivative of h, is equal to 3 times secant squared of the derivative, or of the square root of u squared minus 1 squared times 1/2 u squared minus 1 to the negative 1/2 times 2u. And that's how you take a derivative using chain rule.